Hello students, I'm back with one more case study here. So in this case study what is given? There are two anti-aircraft guns named as A and B, and the probabilities that the shell fired from them hits an airplane are 0.3 and 0.2. So A and B event we can consider as that airplane is shot by aircraft A. Okay. And similarly airplane is shot by B. So probability of A and B is given to us. Probability of A is 0.3 and probability of B is 0.2 respectively. Now both of them fired one shell at an airplane at the same time. That means at the same time they are firing. That means one will not affect the other. Okay, or we can say simultaneously both are firing. That means independently they are firing. Okay, in other words what we can say, they are firing independently. One firing of one aircraft will not affect the other one because they are firing at the same time. Okay, not one after the another. Now let's check the question. Question 1 is, what is the probability that the shell fired from exactly one of them hit the plane? Now exactly one of them hit the plane. A hits the plane or B hits the plane. We don't know. Okay. So if A is hitting the plane, B should not hit. Okay. So actually if you see, probability that exactly one of them hits. So we can say probability of A but not B. Okay, that means P of A intersection B complement is what? That A is hitting the plane but not by B. One of them, no, it's not clearly mentioned which one. So either A can hit or B can hit. So or probability of B but not A. Okay. So since they are independent event, we can write P of A into P of B complement plus P of B into P of A complement. So P of A already we know it's 0.3. So P of A complement will be 0.7 and P of B we know 0.2. So P of B complement will be 0.8. So if you substitute the values, 0.3 into 0.8 plus 0.2 into 0.7. So 0.24, 0.14. Final answer will be 0.38. Okay, I hope it's clear. Here one important point you have to understand. Actually one common error what students think that shell fired from exactly one of them hit the plane. Means either A hits the plane or B hits the plane. Then why can't we find probability of A union B? Okay, but you have to understand that when it is asked exactly one of them hits the plane, so we can say only A hits. This is equivalent to only A hits the plane. This is equivalent to only B hits the plane. But when A union B we find, so as per the Venn diagram also, if you try to understand, A union B will give this whole area. This whole area it will give, isn't it? But we are interested in which area? We are interested in this part. Only A hits and only B hits. So we cannot find this. Okay. If you want to find this also, then what you have to do? P of A union B you can find by this formula we know, है ना? Where since they are independent you can find 0.3 plus 0.2 minus you can find by P of A into P of B, that will be 0.06. So 0.5 minus 0.06 will give 0.44, which is this whole yellow area, but we want only this red and black area. That means again you should subtract intersection, which is again you should subtract 0.06, then only you will get 0.38, same as this. So students directly write 0.44 because this is the concept. So whenever this question will come, one of them hit the plane, better you go with this way. Otherwise, second time you will forget to subtract A intersection B. Fine. So this is actually P of only A plus P of only B, equivalent to these two also. Okay. I hope you understood. It's clear now. Okay, now let's discuss the second question. Question is, if it is known that shell fired from exactly one of them hit the plane, then what is the probability that it was fired from B? Now see, exactly one of them already we found here in the first question. Okay, we didn't assign any event to that. So we can say, let's see be the event. Let's see be the event that shell fired from exactly one of them. Okay. If this C be the event, then now see, if it is known that the shell fired from exactly one of them, that means this is the key word to identify that it is from conditional probability. We should find the probability that it is fired from B. Okay. So that means probability of B, when it is known that, when it is given that C had already happened. Okay. So we know this be a formula for conditional probability, B intersection C divided by P of C. So P of C we know already from question 1, that is 0.38. We should find this intersection. So in this intersection, what it says, P of B intersection C. B means only B will hit the plane. C means exactly one of them hits the plane. So intersection will be, B intersection C will be what? P of B or we can say P of only B. That will be more clear. Okay. So B means what? B will hit the plane. C means exactly one of them will hit the plane. So intersection will be what? One should hit and that should be B. That means only B. So P of only B will be what? P of B but not A. Okay. So we can say that this will be fine. Now P of B into P of A dash divided by P of C we can write. So P of B is 0.2 given. P of A complement we have got already, that is 0.7. P of C from question 1 0.38. So 0.14 by 0.38 will be 14 by 38. Further we can simplify to 7 by 19. So here is the case study. I hope you understood. Thank you.